Last one, I discussed about introduction to CCNA and Cisco tracks and device schedules. What topics and what technology you're going to discuss. The next one is network fundamentals. We have started, right? In network fundamentals, basic 4 points we have discussed, which is what is network and networking, internetwork, internetworking, right? Let me show you last class, the first 4 points and types of networks, LAN and WAN. And basic requirements to form a network is NIC, media, networking device. Networking devices, switches, wireless access point, routers, and firewalls. So let me repeat once again the in 5 minutes. What is the last class we have discussed? The first point is network, right? What is network? The network is interconnection of two or more devices. Networking, communication between two or more interconnected devices. Internetwork, interconnection of two or more networks. Like yesterday we have seen one network diagram, right? In the three networks. So interconnection of two or more networks. And what is internetworking? Communication between two or more different networks is called what? Internetworking. And types of networks. Two or more devices are connected in a local area or limited area. We call it is what? LAN. Example, within a room, within a floor, within a building, within a campus, there are what? LAN. The next type of network is a two or more devices are interconnected in a geographically different location, which we call WAN, wide area network. The two major networks are what? LAN and WAN. So to form a network, what is the basic requirement is a first one is NIC, network interface card. The network interface card generally we use to interface between to form a network. It has a address called MAC address, or we can call it as a physical address, or we can call it as a hardware address. The 48-bit MAC address represented in 12 hexadecimal numbers. The 48-bit MAC address, first 24-bit MAC address indicates OUI, which we call Organization Unique Identifier. Second 24 bits of MAC address, what we call guys? Serial number of NIC. So these NIC cards, NIC card types. NIC card types are what? Ethernet, fast Ethernet, gigabit Ethernet. Ethernet up to 10 Mbps can support. Fast Ethernet can support up to 100 Mbps, right? Gigabit Ethernet up to 1000 Mbps. Okay, these are the types of NIC. So next we have discussed about what? Media. Media in a twisted pair cables, like single pair and four pair, is RJ11 and RJ45. RJ11 is a 2 watts, which is transmission and one for receiving, used for telephone lines. Four pair cables, which is called RJ45 cables, generally used for local network. In RJ45 also we have a different categories, which is Cat5, Cat5E, and Cat6. Cat5 cable, DDR, data transmission rate, 100 Mbps. Cat5E, 500 Mbps. Cat6 cable is a 1000 Mbps can support, right? These are listed files. The next point is we clearly discussed about what? Networking devices. So networking devices are switches, wireless access point, routers, and let me see one network diagram based upon this topology. We clearly discussed where we use routers and where we use switches and firewall. This topology here. Like we have some devices. A device names are PC1, PC2, and PC3. Three computers. So you tell me guys now, if three PCs are desktops, so three PCs can support for connectivity is a wide connectivity. Now to centralize our computers, we require which device? Switch. So switch to PCs we used to connect with via which cables? RJ11 and RJ45. Use RJ45 cables and connect to switch. Right. Similarly, have a printer. Now my printer can support for wired connectivity. Then use RJ45 to connect to switch. Now have one more type of devices in your LAN, which is let's say have a file server (FTP), the mail server like IP phone. If all devices are this your servers also can support for desk like a cables, right? Connected to RJ45 cable to switch. Now from PC1 we can communicate to print. We can communicate to PC2, PC3. What about from PC1? How can access to FTP server? How can access to mail server? Just very simple logic is from switch A and switch B connect one crossover cable. All devices can communicate. The next example, like last three devices, which are PC4 and PC5, PC6, 4, 5, 6 computers are wireless devices like a laptop. So these wireless devices to centralize communication, generally we use which device? Hub, switch, or wireless access point, which device? We use what? Wireless access point. Right. Now take one access point and connect to these devices. Now these all wireless devices can communicate each other. 4, 5, 6 are connected to one access point. Now what about 4, 5, 6 PCs? How they can communicate to mail servers? How they can communicate to printer? Make a one cable, RJ45 cable from switch B to access point. So these all devices are connected to switches on wireless access point means the short form we can say you're all end user devices. End user devices are connected to which devices? Switches and access point. It depends upon your type of device. If it's a wide connected device, connect to switch. If it's a wireless supported, connect to wireless access point. So don't think like all end user devices are connected to firewall or router or some other devices. So end user devices are connected to which devices? Switches and access point. Now from switches and access point only one cable is connected to router to enable communication for two or more different logical networks and router to firewall, firewall to internet. Data transmission happening. So this is a connectivity, but now how PC1 can identify to PC2, how PC1 can identify a printer, then how PC1 can identify a file server. So to identify a device in the network, we required what? Very good. IP address. So today our topic is also IP addressing. Okay, right. Let me continue with today's topic, which was IP addressing. Today, we'll discuss about IPv4 address, completely logic of IPv4 address. In the next session, we'll discuss about IPv3, IPv6 also. So can you please read these points? All right. Can you hear me, guys? See, IP address is a logical address. The layer 3 address. What is a layer 3 address? We'll discuss in the next class. There's the two versions, IPv4 and IPv6. IPv4 is 32-bit address. See, before IPv4 address, first I'm telling is today you're going to discuss about what? IP address is logical address. You know why we call IP address is a logical address? You know why? Because we are going to discuss about lot of logics in this address actually. So don't miss any one of the logic. So completely today class is about what? Logics. So try to more focus on it. So what is our today topic, guys? What is our today topic? So today topic is a not a IP address. Today topic is address. So have a two different terminologies. One is IP, one more is what? Address. So today we'll discuss about what? IP, later we'll discuss it. So first we'll focus on address. Generally, what is the use of address? Identification purpose. Like if I know your address, I can identify you, I can reach you, I can trace you. Each and every person we have one unique address. So based upon that address, we can identify you, right? Similarly, in your network, it can be a local network, it can be internet. So within your office, one device have to identify another device. And from your laptop to internet, in internet, number of websites, number of servers are available, right? So every device can identify based upon what? Address. That address we call IP address. Okay. So to identify a device in a network, we require what? Address, which is IP address. Now, can you tell me what is some IP address examples? Can you text me, please? You know any addresses? 192.168.1.1, 13.14. Okay. 11.1.1.2, 10.0.0.1. Right. Let me prepare some list here. 255, 255, 255.0. Okay, Rakesh. 10.0.0.1. 11 dot something 001 and 192.168 1.1 186 10.1.2 224 10.10.2 and 248 10.1.2 something IP address like 8.9.2.9 194.20.20.8. These all are addresses, right? So what is the use of this addresses? So what is the logic here? We are using here some number 10 and later had using one some dot. Again using some number. It can be any number 186. Again you are using what? Dot. Again you are using some number 0. Again you are using dot. Again using 2. Like what is exactly first value, second value, third value, fourth value? So what is the logic here? So we'll clearly discuss all the logics today. So IP addresses have a two versions. One is IP v4, another one is what? IP. So IPv4 is a 32-bit address, the form of what? Binary, means 0 and 1s. So these IPv4 represent in decimal format. So IPv6, we have a separate session for IPv6. We'll discuss later about IPv6. So today we'll more focus on IPv4 address. Now IPv4 is a 32-bit address, right? That means this IPv4 32-bit address is a combination of 0 and 1. Either all 32 zeros or all 32 ones, or a combination of 0, 1, 1, 0, 0, 1, like combination of 0 and 1, right? So let me take one example, combination of 0 and 1, and we'll clearly discuss about logic. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 17, 18, 19, 20, 21, 22, 23, 24, 26, 27, 28, 29, 30, 31, 2, right? So this is a one address to identify a device. This is address actually, right? This address we use to configure to identify a device. So machine language is what, guys? Binary. Device can understand what is 0, what is 1, 0 and 1, like. But as a user, can we understand, guys, as a user, the user language is we are very familiar with what? Decimal numbers, which is 0, 1, 2, up to 9, 0 to 9 numbers, we are familiar, right? This is user language. But machine language is a binary language, right? So what we do means we need to convert from binary to decimal language. So before converting binary to decimal language, what we are doing is a complete 32-bit address are being divided into 4 portions. So each portion technically we call octet. So one octet is equal to 8 bits. Like we have a how many octets here? 4 octets. 4 octet is equal to 32. Each octet, first octet, second octet, third octet, fourth octet, like each octet is being separated by using dot. So first 8 bits, dot, second 8 bits, dot, third 8 bits, dot. So each octet is being separated by dot. By seeing the dot, my device can understand, okay, it's the first octet, the second octet, is the third octet, like this actually, right? Now to convert from binary to decimal languages, use one scientific formula. Let's say is 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7. Like first octet, each octet, how many bits? 8 bits, right? Here 1, 2, 3, 4, 5, 6, 7, 8. 8 bits. So what is the value of 2 power 0? Like any power 0 is a 1. 2 power 1, 2, 2 power 2, 4, 8, 16, 32, 64, 120, which is 2 power 7. These are all the values. Is it okay? Can you hear me properly? My voice is clear on the screen. Let me write something on the screen. I'm going to writing here A, B, C. Can you exactly see here? A, B, C. And 2 lines are written. All right. If anything mistake, if anything wrong, like any problem, just text me. Let me check from my side, and you can check it from your side also. All right. Let me continue. Now 0 and 1s. It's a binary, right? IPv4 is a combination of 0 and 1s. 0 indicates your bit is a off. 1 indicates your bit is a on. I repeat once again. 0 indicates what? Bit is off. 1 indicates your bit is what? On. The first octet 0 1 0 1 0 0 0 1. So first bit value. What is the first bit value? 128. First bit value is a 128, 64, 32, 16, 8, 4, 2, 1. Now 0 indicates what? Off. Like in first octet, which bit values are on bits, which bit values are off bit, guys? So here 64 is a on, 64 is on, 16 is on, and 1 is on. So total it 64, 16, and plus 1. What's the value? So first octet value in the decimal language is what? 81. Similarly, second octet. First octet is a 128 is off. Second octet 64 is on. 32 is on. 16 is on. 8 is off. 4 is on. 2 is off. 1 is on. The total 64, 32, 16, 4, and 1. What's the total value? Right. 117 dots. Similarly, try to calculate for third octet and fourth octet and tell me the answer. Do it fast. Try to do third octet value, fourth octet value. Right. Third octet is what? 154. Last octet value is what? 60, 67, right? Exactly. So like we can convert from binary to decimal. Like finally IP address is what? 81.118.154.67. So this address now you as a user we can understand, but how machine can understand? So machine can understand 010101 dot 01110101 like this, right? So not only how to convert from binary decimal, let me see how to convert from decimal to binary. I have already one IP address is there, which is 192.168 dot 10.6. 10.6 is my IP address. It's already decimal. Like how we can write in the binary language? First octet 192. How can write it? The two methods. The first one is a 192. If we do for LCM, then you can get binary language, binary values, right? It's a very lengthy process. So instead of that, 128 plus 64. If you take this chart, example here, 128, 64, 32, 16, 8, 4, 2, 1. 128 plus 64. How much like? 192. So means 128 place is on, 64 is a on. Remaining all bits are what? Off bits. 0. So 192 we can write like is a 11000000 like. Last one, 6. The value is a 6. How you can write a 6 in the binary? Which two values can combine is a 6? 4 plus 2. 6, right? So means 4 is a 1 and 2 is 1. Remaining all are what? Zeros. So 6 we can write as a 0, 0, 0, 0, 0, 1, 1, 0. Like. Similarly, can you tell me how about 10? How you can write as a 10? 8 plus 2, right? 8 plus 2 is a 10, right? Means 8 place is 1, 2 place is 1, remaining all are what? 0. It means here 0, 0, 0, 0, 1, 0, 1, 0. These are the one of the method, or you can go for LCM also. So take 168 and do LCM, you can get the value. So like this, we can convert from binary to decimal and decimal to binary. Clear that? Just only reduction. Now let's say IPv4, total how many IPv4 addresses are available? So what is the starting IPv4 address and what is the highest IPv4 address? And what is the range of IPv4 address? What is the possibilities is? Let me try to discuss clearly on it. IPv4 is a combination of what? 0 and 1. How many bits? 32 bits. IPv4 a binary which is 0 and 1. In 0 and 1, which is a least bit? 0 and 1. Which one is the least bit, guys? 0 is the least. And which is the highest? 1 is the highest, right? So if we take 32 zeros, starting IPv4 address. If you write it as a 32 ones in 4 octet format, is the highest IPv4 address, right? Let me write this now clearly. First octet least 1, 2, 3, 4, 5, 6, 7, 8. First octet least. Same like a second octet. Second octet least. Third octet least. And fourth octet. So this is starting IPv4 address all 0. What about highest? Ones. 1, 2, 3, 4, 5, 6, 7, 8. Dot. First octet highest. Now second octet highest. Third octet. Fourth octet. Is the range of IPv4 address. Now you tell me guys, this is a binary language or decimal language? It's a binary, right? Now as a user, what will you do? Convert to decimal. If it's all zeros, what is the value? 0. Dot. Second octet, 0. Dot. Third octet, 0. Fourth octet, 0, 0, 0. If now highest is all ones, right? Means first bit is a 128, 64, 32, 16, 8, 4, 2, 1. If you total it, value is a 255 or 256. It's a 255 dot 255 dot 255 dot 255. So 0002, 255, 255, 255, 255 dot. So this is a range of IPv4 address. In between we have 4.3 billion IP addresses. Mustafa, can you hear me, Mustafa? IPv4 address range is a 4.3 billion. Total IPv4 address is what? 4.3 billion IP addresses. This is the range. 0002, 255, 255, 255 dot. Right? And copy this slide. Total IP address range is the range. So 4.3 billion IP addresses means the combination of 2 power 32 combinations. 2 power 32 combinations are what? 4.3 billion. Now, is all 4.3 billion IPs are being classified into 5 classes. IP address classification. So IP address are divided into what? 5 classes. Class A, Class B, Class C, Class D, and Class E. First, Class A, Class B, Class C are used in LAN and WAN. Class D IPs are reserved for multicasting, and Class E IPs are reserved for research and development. All 5 classes are different purposes are being reserved. The purpose is first ABC classes. Class A, Class B classes are reserved for what? Local network and wide area network, LAN and WAN. Class D, complete Class D IP address range reserved for multicasting. They have different type of communications like a unicast, broadcast, multicast, right? So once our routing algorithms, routing is started, we clearly discuss about what is multicasting and where we use multicast IP addresses and where we use broadcast IP address. So those things we discuss about today. And Class E IPs are reserved for what? Research and development, R&D purpose. Copy it now. All the classes, class A, class B, class C. We have some IP addresses in the list right here. Starting IP 4, we have discussed some IP 4 addresses like 10.0.0.1, 11.1, 192.168, 186. List of IP address, which IPs belongs to which class? The first IP address, 10.0.0.1. Is it class A or class B or class C? Second one, is it class A or class B or class C? How we can identify? You know what? So based upon ranges. So based upon ranges, right? So class A, we have some ranges here, like from 0.0.0.0 to 255, 255, 255, 255. So between this range, so some range of IPs are being reserved for class A, some range of IPs are reserved for class B, class C, class D, class C, like this. What's the class A range? The IP address is starting from 0 to 127. The class A address range. Class B address range 128 to 191. The thing is, what was the logic here for class A 0 to 127 only? Like why not 0 to 128? What was the logic exactly here? 0 to 127. 0 to can be 50 also. 0 to 10 also. For class B 180 to 128 to 191 only. What was the logic here? The logic is all the class address ranges depends upon priority bit. Priority bit is used for IP address classification. Most Symphony sends are bits from first octet of priority bits. From first octet, your IP address from first octet, first bit for class A is reserved. First 2 bits for class B, first 3 bits for class C. From first octet, first bits actually, right? See priority bits. Class A priority bit is a 0 from first octet. Class B bits are 10 from first octet. Like all are from first octet are selected. Total number of priority bits for class A 1. For class B 1 0 means what? 2 bits. For class C 1 1 0 means how many bits? 3 bits. For class D 1 1 1 1 0 4 bits. For class E 1 1 1 1 like how 4 bits is it actually, right? So based upon this priority bit, we can classify it easily. Let me explain clearly how differentiate the addresses range. These all priority bits are reserved from which octet, guys? From where? From the first octet, right? So let me take first octet value. I'm writing first octet here. 1, 2, 3, 4, 5, 6, 7, 8. Lowest first octet value. Highest first octet. 1, 2, 3, 4, 5, 6, 7, 8. This is the first octet value, right? Now for class A, how many bits are being reserved for priority bits? Only 1 bit. I am separating only 1 bit. But 1 bit is a which bit? 1 bit is a 0. So make the first bit as a 0. I'm making the first bit is what? Is a 0 here. So if you see, first one is what? 0. Okay. Now this is a binary language, right? Now try to convert into decimal. Like all zeros. 0. Actually all ones, but first bit is converted to 0, it is 128 is being off. Remaining all bits are on, which is 64 is on, 32, 16, 8, 4, 2, 1. If we total it, what's the value? We can get 127. 0 to 127 is the range of class A address, but this range is from only first octet. What about second octet? 0, 0, 0. Highest 255.255.255. So this is complete class A address range. So IPs are starting from 0002, 127, 255, 255, 255. In between, all IPs are belongs to which class? All IPs are what belongs to what? Class A addresses. Okay. Let me explain one more example who are getting confused. Let me explain one more example. Try to understand clearly. So just I am writing is a first octet values. Lowest first octet 0, 2, 3, 4, 5, 6, 7, 8. The highest first octet 1, 2, 3, 4, 5, 6, 7, 8. For class B, how many bits are being reserved? 2 bits. So let me make separate as a 2 bits. Now 2 bits are, which 2 bits are being reserved? 1, 0, right? So make this as a 1, 0. So first 2 bits in the lowest and highest, you have to write is what? 1, 0. So first bit value is what? 128. 128. Dot. For highest, all bits are ones, but which is off here? 64 is off. Means 255 minus 64 you can get, right? What is the value? 191. So 128 to 191 is a class B range from first octet. What about remaining octets? 128.0.0.0 to 191.255.255.255, right? 191. 128 to 191. These are the class B range. 128 to 191. Okay, guys. Now your task is try to do the calculation for class C, class D, and class E addresses, and tell me the range of C, D, E ranges. Do it fast. Class C, class D, and class E. So class C priority bits 110. For class D 1110. For class E 1111. Okay, Ram. All right. For class C, range is 192.0 0.0.0 to 223 dot 255 dot 255 dot 255, right? Now class D range 224.0.0.0 to 239 dot 255 255 255, and finally class E range 240.0.0.0 to 255 255 255 dot. Color class A, class B, class C, class D, and class E range. Okay. Class A range, class B, class C, class D, and class E range. So try to take a screenshot on it. So here I have a list of IP addresses. List of IP addresses. First one 10.1.100.1. So these IPs belongs to which class? Starting from 10, right? By seeing the first octet. So 0 to 127. IPs are belongs to what? Class A, right? So first one is what? Class A IP address. Second example 192.111. Which class IP address? Right. Class C, right? The next one is a 120.200.1.1. Which class IP address? So my question is 120.200.1.1. Class A, right? What about 224.0010? 224. So 224 is a class C or class D? Class D, right? Up to 223 is a class C. 224 is a class D means. So this IP address is being reserved for what purpose? So all class D IPs are reserved for what purpose, guys? Multicast. So can you use for LAN and WAN? 224.0010. This IP address can use for the LAN and WAN, guys? No. The LAN and WAN we can use only for which class IP addresses? Either class A or B or class A, B, C only. So we cannot make use a class D and class C IP addresses, right? And 150, 150.17.2.200. So these IPs belongs to which class? Class B. Right. The last one, last example is belongs to which class? Class. So 17.1.256. So 256 is valid IPv6 IPv4 address. So maximum from any octet is a 255 only, right? So means is a 256 means is a invalid. It's not valid. See, all the guys here are concentrating on only in first octet. So don't do like this. So first read the complete IP address and find out the address. So first you have to find out is it valid or not. If we take this example here, 17.1.256.1, this is invalid IPv4 address, right? Yesterday, first point we have discussed, do you remember? Last session we have discussed, first point is what? Network. What is network? So network means two or more devices are interconnected, right? Let me design one, let me one diagram here. Device 1, device 2, 3. Like all devices are connected to switch with RJ45 cable. So these all those things we call what? It is a network. In network, how many devices are available here? So each device now network we called host. Network is one, host is what? So for these devices, to enable communication, to identify a device, we have to assign IP address, right? So we have IP addresses are class A IP, class B IP, class C, class D, class E. Out of 5 classes, which class IP address do you recommend to assign for 6 devices? A, B, C, or D, or E, which class IP address? So can you use the class D IP address? No. Class D IP is the reason for what? Multicast. Can you use the class E IP address? No. Because for R&D purpose, right? So we can make use only which class IP addresses? Class A, class B, and class C only. Again, my question is here, from class A, B, C, which class IP is being recommended? A or B or C? So this is very, very important point here. It depends upon requirement. So where we use class A IP address? And what type of scenarios and what type of networks we use class A, class B, class C? So that knowledge as a network engineer, we have to know. Because we are going to decide which class IP address, right? So how can decide means is based upon requirement. Your IPv4 address are being divided into networks and hosts. Network portion and host portion. For class A, first octet. First octet is a network. Second octet is a host. Third octet is a host portion. Fourth octet is what? Host. For class B, first two octets are network portion. And next octet is a host portion. For class C, first octet, second octet, third octet is a network portion. The last one is what, guys? Now my requirement is here, network is 1, host is 6. So which requirement is more? Network requirement or host requirement? Host requirement, right? Now in which class you can get more hosts? So class A is recommended. So which class we choose means it depends upon what? Network requirement and host requirement. For example, I need a very large number of hosts. The railway department. If you like a railway department, have a very huge network, right? Number of thousands of hosts are available. So which class is recommended, guys? Class A. Let me take example is a Geo network. Like India wide, network is only one, which is Geo. But how many customers are connected to Geo? How many users using network, Geo network? Lakhs of people. So for each and every people is a required one IP address, right? So which class IP is recommended? The thing is a home at your homes. At your homes maximum how many devices you generally use to connect? Your mobile, your laptop, like 5 to 6 devices, right? So means very few number of hosts, very less number of hosts. Then which class IP address is recommended for less number of hosts? Class C. So that's the reason generally we are all very familiar with 192.168.1.1 IP address. Even if you open your command prompt and if you check your IP address, you can get IP address is a 192.168 series. Let me check my laptop IP address now. Command prompt. I'm using IP config command. Enter. And see here 192.168.0.7 I'm making use, right? Even class A, because very medium, very small network. Now my requirement is here, I need a 250 network. 250 networks I need. Then which class IP address do you recommend? A or B or C? Networks. Yeah, Salman, Rakesh, Raja, Prakash, Pradeep, Nikhil, Nagashiva. Can you hear me, all of you guys? I'm getting a reply from very few only. So now my question is here. I need a 250 networks. Which class do you recommend? A or B or C? Let me look for the which class IP is recommended. See, if my requirement is a 2500 network, in which class? If my requirement is a 25 networks, 25 networks I need, then yeah, this is very important point actually. Like we don't know about how many networks are available in class A, how many networks are available in class B and class C. We know only class A, first octet is a network portion. Class B, first two octets is a network portion. Class C, first three octets, right? But we don't know exactly number of networks in class A, number of networks in B and C, number of hosts in A and B and C. We don't know the numbers. We know only, we just now we have discussed about what? Class A, first octet is a host. Remaining three octets are host network. First octet is what? Network. Remaining three octets is what? Host. But we don't know about exactly value, right? Number. Let me calculate about clearly in class A how many networks are available. Each octet equal to how many bits, guys? 8 bits, right? So first octet is a 8 bits. Second octet 8 bit. Third octet 8. Fourth octet. Class A, total number of network bits. Network bits, total number of network bits are what? 8. For class A, total number of host bits. Total number of host bits. 8 plus 8 plus 8, total is what? 24. Clear, guys? Are getting the point? For class B, total number of network bits. Network bits are what? 16. For class B, total number of host bits. Total number of host bits are what? 16. Like in class A, total number of network bits. Total number of network bits are what? Network bits. 8 plus 8 plus what? 24. Total number of host bits are 8. Now, we'll back to priority bits. The priority bits for class A, one bit is a priority bit. For class B, 10, 2 bits. For class A, 1110, 3 bits, right? Priority bit for class A is what? 1. For class B, 2 bits. For class A, now let me discuss clearly. The first calculation based on number of networks. Number of networks, we'll see it now. For number of networks, generally we use one formula is to power number of network bits minus priority bits. Okay, guys? The formula for class A, class B, class. Same formula. To power number of network bits minus priority. Now let me go for class A example. Class A. For class A, what's the formula? To power number of network bits. To power number of network bits in class A. 8. Minus how many priority bits? 1. Means 2 power 8 minus 1, which is 2 power 7. What is the value of 2 power 7, guys? 2 power 7 value. 128 networks only. So maximum in class A we have how many networks are available? 128. If I need 10 networks, then use a class A. If I need 20 networks, use a class A. If I need 150 networks, then I choose a class A, guys. So maximum is A. In class A, how many networks are available? 128. The thing is here, out of 128, all 128 networks are not usable. Here, 2 networks are minus. So 128 minus 2, 126 networks are valid. But why 2 networks are minus? Why 2 networks are not usable? You know why? Because so we are calculating for class A, right? So tell me first class A range. What is the class A range? Class A range is a 0 dot 0 dot 0 dot 0. Next 1 dot. Next network is 1.0.0.0, 2.0.0.0, like 3.0.0, like up to 126.0.0, like 127.0.0, right? This is a classic range completely. The first one, which is a 000, so this is not a usable network. So this we call global ID. Like all 4.3 billion IP address identification is a 000 default ID. So this we call is what, guys? Is a reserved for what purpose? Is a global ID. Similarly, last one, 127.0.0 is also not usable network. So this network we call it is a loopback ID. Loopback ID. Global ID for 4.3 billion IP addresses identification purpose. But what is the purpose of loopback ID? So generally, your computers can work with operating system, right? In your operating system, along with your operating system, we have TCP IP protocol stack is available. So in your PC, TCP IP protocol is working or not. So to check TCP IP protocol, we use loopback address. Like just let me check my computer TCP is working or not means in my command prompt I use one command called ping 127.0.0.1. So you enter, if it's getting reply means so in my computer TCP IP stack is being completely working. So when you ping to 127.0.0.1, if it is not giving reply, TCP IP stack is not properly installed. TCP IP is not working properly. So loopback IP address we used to check for what? Testing TCP IP in the local device. 127.0.0.1 is a local device, not broadcast. Only local device itself. Isolated, like I can say. Like we like a 127. The present situation in India. Don't be like a 255, 255, 255. So 255, 255 is what? Broadcast. Roaming and all the roads. So the reason here, two networks are minus. Why minus to here? One for global ID and one more for what? Loopback ID. So this minus 2 only for class A. No class B, no class C. Only class A. The class B total networks are valid. This which is 2 power 16. In class C, 2 power 24 minus 3. In class B, 2 power 16 minus 2 is priority bit. Okay, guys? Make it down. You can copy it. You can just take the screenshot. Right? Yeah, Prakash. Minus 2 only for class A. Means global ID and loopback ID only in the class A. In class B, no minus 2. Total networks are working. Class B. For class B, 2 power number of network bits 16 minus priority bits. How many priority bits for class B? 2, which is 10, right? It's minus 2. 2 power 14 networks are valid. For class C, 2 power 24 network bits minus priority bit. is 110 minus 3 means 2 power 21 or 12. No minus 2 here. So you can calculate yourself 2 power 14 and 2 power 21 value, you can get some value. That much of networks are available in class A, class B, and okay, guys. So based upon your now your network requirement, now based upon your value, if you need a 50 networks, happily you can use class A. If your requirement is a 100 networks, use class A. If your requirement is a 2000 networks, then which class is recommended? 2000. Class B, right? Even class B, we are getting 2 power 14 networks. Like this. So similarly, let me calculate for host, number of hosts. Host calculation, what do you do? Number of hosts. For number of hosts, same formula. 2 power number of hosts. 2 power number of host bits minus 2. Not power minus 2, it's a base minus 2. 2 power number of host bits. Base minus, not power minus. First, let me calculate for class C. 2 power number of host bits in class C. 8 minus 2. 2 power 8. 256 minus 2. 254. What is 254? 254. 254 are what? Valid hosts for each network. For each network. Say for class B, for class B, 2 power 16 base minus 2. 65,536 minus 2. 65,534 valid hosts for network. For class A, 2 power 24 base minus 2. 16,777,216 minus 2 is very large number of hosts. Valid host for each network. So my requirement is a in my home I have a like 5 to 10 devices. Mostly 5 to 10 devices are available, including my laptop, phone, CVs, all those things. So which class is recommended? A or B or C? Class C. So in my company, so total I have a 200 hosts, 200 computers are available. It's a very small office I have actually. Then which class IP is recommended, guys? Class C. Like have a medium organization, so have a nearly like 800 computers in my office. Or maybe 8,000 computers in my office. And which class is recommended is a class B, like up to 65,000 plus. We can use what class B? Have the more than 65,000 plus. If it's a banking sector, if we go for SBI, very huge number of courses available, right? Then which class IP is recommended? Class A. So like this, as a network engineer, we have to decide which IP is for which companies, which network requirement, and host. Based upon that, we'll decide it. But the thing is, main point is here in host calculation. Number of host calculation, we are doing two IPs or bases here, right? -2 in class B, -2 in class C, or -2 in class A. Like each and every network, we are doing -2. For what? What is the use of it? Why -2 here? In number of network calculation, in the class A, -2, one for global ID, one more for loopback ID, right? But here, the purpose of -2 here, post calculation. Network ID and broadcast. Let me discuss what is network ID and broadcast ID clearly. I'm taking one IP address example, class A example, 10.0.0. What will be the next IP address? Next IP address is 10.001 or 10.1.0.0. 10.0.0.1. Next, 10.0.0.2. Like 10.0.0.3, 10.0.0.4, 10.0.0.5, up to which IP address? 10.0.0.250. Next IP address. After 255, what will be the next IP address? 11 dot or 10 dot? Okay, Pradeep. Let me explain clearly now. You know how IP address format is a example, your bikes, vehicles is a new vehicle, your bike speedometer 0, 0, 0, 0, right? These are the numbers, they're all zeros. How ride a 5 kilometers? So where number will change? The right side or left side? Right. The last number will be changed as what? Because of last number, if first number is changed, then how many kilometers we ride? 5,000 kilometers, right? So number is changing on to last one is the 5 kilometers. All right. After 9 kilometers is been done. So what is the number? Next number is what now? 0010 means what? 10 kilometers. Now 0011, 0012, 13, 14. Like after 99 kilometers. What's the number, guys? 0, 1, 0. Right? The same like your IP address format also here. Now we have started from where 10.0.0.0, 10.0.0.1, 2, 3, 4, up to 255. If 255 is being finished means what, Pradeep? What's the number now? Exactly. Now it's going to start from where? 10.0.1.0, 10.0.1.1, 10.0.1.2, 1.3, 1.4, 1.5, up to 10.0.1.255. Okay, what is the next IP address? Right, perfect. 10.0.2.0, 3.0, 4.0, 5.0, 6.0, like up to 10.0.1.255. 255.255. Then what will be the next IP address? 10.1.0.0, like 10.1.0.1, like 10 dot, like again 2.0.0, 3.0.0, like finally, what will be the IP address, guys? 10 dot 255 dot 255 dot 255. So this is completely a 10 dot network address range. Now only next IP will be what? 11 dot will be changed, right? Okay. You know what? 10.0002, 10.255, 255, 255. In between total, how many IPs are available? Actual IP address, not in this example. Don't count one. Don't count like how many IPs, 1, 2, 3, 4, not like that. Actually, 10.0002, 10.255, 255, 255. In between, how many IP addresses? We already discussed, right? We already calculated this here before. So for class A, each network of class A, how many valid IPs are available? 16777214. Actually 216. Two IPs are minus, right? So between we have how many IP addresses? A 167771214 IP addresses. Actually 216, but two IPs are minus. Why two IPs are minus is a one for network ID, one more for broadcast ID. So what is network ID and broadcast ID? Let me clearly discuss. Here, our participants, we have many participants available here? 16, almost 16, right? So now is all are Zoom students, right? Like how we can identify Zoom student? Based on what? ID card. See, every day I used to tell, try to log in with your name and Zoom ID, but you are not doing that. Only very few people is doing like a Ram is doing that, and Sanjeev is being logged in like that only. Agasiva is also good. Okay, like you log in as online, paid on online. Good. So everyone try to log in along with your name and your Zoom ID. Like what's the Zoom ID? Let's say Zoom ID is one ID. Let me take here Ram ZTAM 68792. 792, right? Z ID. This ID is a Z Zoom Technology AM Amir Page and 68792 is the ID number. Actually, Zoom organization ID is ZT Zoom Technologies Amir Page 0000. Is my organization ID. ZT AM is the organization ID. Now, who joined for the student for first student in the Zoom organization? What will be the ID card, guys? What is the ID number? ZT AM 00001. Exactly. Right. Second student ZT AM 00002. Like here, number of students are being joined. Now RAM number is what? 68792. 001, 002, 68792. Remaining all IP, like all numbers are provided by students, issued by students, right? But what about first one? ZTAM000. So these ID, can you give for students? Can you use for students? No. This is only for what? organization ID, right? It's only for identification of company organization ID. Similarly, same example in your IP addresses also. The first one, which is a 10,000. So this is we cannot make use to assign your computers. We cannot make use of that. So 10,000 is a only for identification purpose, which we call is a network ID. So we can start using from where 10,001, 10,002, 3, 4, 5. Like is all IPs or you can use it. These IPs we call it is a usable IP addresses. But first one 10,000 we cannot make use it. It is only for what? Identification purpose. Similarly, last one which is 10.255, 255, 255. So this IP address for broadcasting purpose. We call it is a broadcast ID. Why two IPs are managed? One for network identification and one more for broadcasting purpose. Like network ID and broadcast ID, in between all IP addresses are, we call it is a valid IP address or usable IP addresses. So first one is network ID. The last one, which is 255, 255, 10.255, right? 10.255.255.255. So this we call it is what, guys? Is a broadcast ID. Network ID and broadcast ID between all IP addresses we call valid IP address. Valid IP. How many valid IPs are available between 16777214 IP addresses? 216 actually minus 214. So this is a class A example. Now tell me guys, I have one IP address which is 10.9.1.2. This is a usable IP address or not usable IP address? 10.9.1.2, is it usable? Yes, you can use. Right, what about 10.0.0.0? Can you use it? No. Why? It's a network ID, it's a identification purpose, right? So when you're working in your real time, when you're working in your organization also, make sure that which IPs are usable, which IPs are not usable, which IPs are network IDs, which IPs are broadcast IDs, which IPs are class A, which IPs are class B and class C, which IPs are class B and class E. These all the logics we need to keep in mind, we need to run in the mind when you are working in your real time. So next question is here, like 18.9.1.1 have an IP address. This IPs belongs to which class? 18.9.1.1 is a class A. Okay. Now this IPs belongs to which network ID? 18.0.0.0. Perfect. Why 19? Okay. 18.9.1.1, right? Okay, no problem. Typing problem. 1800 is what? Network ID. Perfect. The next question is I have a 186.10.1.2 is IP address. So these IPs belongs to this IP will be, what will be the network ID? 186.10.1.2 network ID. 186.0.0.0 is Wrong. So now let's see here how to identify network ID and broadcast ID. So before identifying network ID and broadcast ID, so first identify these IPs belongs to which class. If you know the class, then you can easily understand which class, which is network ID. It's a class B, right? Very good. It's a class B. For class B, network portion, host portion, can you tell me? Network portion, host portion. Class B, network, network, host, right? First two octets are network, and second two octets what? Host. Let me write here like the same thing. First octet is what? Network. Second octet is network. Third octet is a host. Fourth octet is what? Host. So to identify network address, the host portion. In host portion, if you write is a 0, network ID. In host portion, if we make it is a 255, it's a broadcast ID. Is a logic for class A also, class B also, class C also. Zeros in network portion is a network. Zeros in host portion is a network ID. 255 in host portion is what? Broadcast ID. Example is here 191.168.2.19. Can you tell me what is the network ID of this IP address? Network ID of this IP address, please. What about remaining guys? Not getting reply from you. So try to give the reply fast. Very good. Perfect. All answer is right. Why? Because it's a class B, right? 191 is a class B. So class B, first two octets are network portion. Remaining two, first two octets are what? Network portion. Remaining two are what? Host portion. Means what I'm writing is here 191.168.0.0 is the network ID. What will be the broadcast ID, guys? 191.168.255.255 is a broadcast ID. Perfect. So means what do you mean 191.168.2.19 is a usable IP address or not? This is valid. See, valid IP address. So first one is network ID, last one is broadcast ID. In between, all IPs are belongs to what? Valid IP address. Between all IP address means how many IPs are valid in the between? Actually, 65,536 IPs are available, but out of 65,536, two IPs are minus, one for network ID, one more for broadcast ID means 34. 65,534 IPs are what? Valid. Yeah, broadcast purpose we'll discuss later about it. Once your routing is being started, we'll discuss. Example of what class B. Let's say one more example. 192.168.2.0 is it valid IP address? One ninety two 168.2.0 is it valid? So first identify this IPs belongs to which class? It's a class C. So for class C, first octet is network, second octet is network, third octet is network, last octet is what? Host. The host portion already we have what? 0, right? Means it is a network ID. It is not valid IP address. We cannot make use this to assign a computer, right? So 192.168.2.198. Is it valid? Yes. The valid IP address. 192.168.2.255. Is it valid, guys? No. Why? Yes. Why? Because it's a what? Broadcast ID. Finally, now you tell me, guys, 192.168.2.10. This IP address will be, what is the network ID of this IP address? 192.168.2.0. Broadcast ID is what? 192.168.2.255 is a broadcast ID. Between all IPs are what? Valid. Now you tell me, guys, between how many IPs are valid? 256 actually. Out of 256, two IPs are minus. One for network ID and broadcast ID means 254 are valid. Okay, 254 are valid. So here, which is very important point is, so listen everyone clearly. Now out of 254, what is the first usable IP address? What will be the first valid IP address here? First usable address. 192.168. 2.1. Perfect. So these first valid IP address generally we used to assign for as a default gateway address, which is router IP address. From any class, class A or class B, class A, first valid IP address we dedicately assign for what? Router. Recommended, not mandatory. Like 2.1 only have to use the router. No, not like that. You can use any valid IP address, but recommended is what? 2.1. Even let me check my computer. What is my gateway address? You see here 192.168.0.1, which is first valid IP address, right? Even if you check your computers, you can gateway address is a first valid IP address you can get. So mostly like 99% we use first valid IP address or last valid IP address. What will be the last valid IP address, guys? 192.168.2.254. So mostly we use what? First valid IP address only. Yeah? You can copy the points. This point clearly can understand. Network address. IP address with all bits as zeros in host portion. Broadcast address. IP address with all bits ones in host portion. Valid IP address lie between network ID and broadcast ID. The last point is what, guys? Only valid IPs are assigned to host or client. Means we cannot make use network IDs on broadcast IDs. Copy. All right. Here I have some questions here. I'll solve this question. Identifying valid IP addresses. One, keep reading the open your chart box. So first example, 119.1.1.1. Is it valid IP address? Yes or no? Yes, it's valid. Very good. Very good, all of you. Second example, 172.17.255.255. Is it valid IP address? No. Why? Very nice. It's a broadcast ID. Why? Because in the last four portions we have what? 255 is there, right? Is a no, we cannot use it. Invalid. Is a not invalid actually. It's a broadcast address. Invalid means what? Out of 255. It's invalid. 256, 257. But is what? Broadcast ID. 172.17.255.255 is a broadcast. Next question. 11.1.0.0, is it valid? Yes or no? So few people are selling is yes, people selling no. Read the IP address clearly. 11.1.0.0. Ram, come on. Right, Salma. Let me explain this. Eleven dot one dot 2.9. What will be the network ID of this IP address, guys? 11.0.0.0 is a network ID. 11.255.255.255 is what? Broadcast ID. In between, all IPs are what? Valid IP address. 11.0.0.0 is a network ID. Now, what about 11.1.0.0? Is it valid IP address or not? Yes or no? Same question I'm asking here. 11.1.0.0 is a yes, is valid. If it's 11.00, then is a network ID. Next question. 195.255.0.255, is it valid? Between, come on. Come on. How it valid? It's a class C, right? It's a class C IP address. First octet is network, second octet is network, third octet is network, last octet is what? Host. The host portion we have what here? 255. The host portion if it's a 0, network ID. Host portion if it's a 255, broadcast ID, it is not valid. Okay. Now, last example, 142.10.0.0. It's a perfect, it's a network ID. Not valid, it's a network. So like we can in the real time also, we can easily find out which IP is a network ID, which IP is a broadcast ID, and which one is a class A, which one is a class B. Like all about these logics we clearly understand. That's for today. Today, IPv4 address logics we have discussed. Still, we have some logics is there. So tomorrow also, let me continue with same IPv4 address and IPv6 also, like private IP address, public IP address, and subnet mask calculations. Like still, we have a lot of logics how to discuss. The next session, let me continue with the same class. Regarding today's topic, if you have any doubts, you can ask me now. Let me tell you once again, everyone, listen carefully. I'm sharing one file to all of you. I'm sharing one link here. Copy this link, everyone. If you open this link, Zoom will ask you about your details. So who registered this? Who filled your form? So those people only can get recording session.